Comparing crystals. So at times you'll be asked to compare the strength or the properties of different network solids and their crystals. So here is a chart to help you understand better and organize how the forces that hold the units together and the general properties that are associated with each of them. So we have each of the four types of crystals. We have ionic, which is held together by electrostatic forces of the ions that are in there. And the general properties are they're hard, brittle, that means easy to break, high melting point, and poor conductors of heat and electricity. So an example of that would be table salt. Something you use every day is an example of that electrostatic force. Now, they are poor conductors of heat and electricity in solid state, but when they are in water, when their ions can flow freely, they become good conductors of heat and electricity. So they are different in aqueous form. So that's very unique about ionic crystals. Then we move on to covalent crystals. These are held together by covalent bonds. They are hard, they have a high melting point, and they're also poor conductors of heat and electricity. But most of the time, they are insoluble in water. And an example of that would be a diamond. And sometimes you might hear that it's called a covalent network solid or crystal, and they're talking about the fact that it is in a network. Molecular crystals, though, have a dispersion forces, dipole forces, and hydrogen bonds. All these bonds are weaker than ionic and covalent bonds, making it have different properties, like it being soft, having a low melting point, but they are also poor conductors of heat and electricity. Now, the last one we have is metallic crystals, which are held together by metallic bonds. But the uniqueness of metallic bonds is that their valence electrons, I'm going to abbreviate electrons like that, E with a negative, electrons are delocalized. So they don't have to stay with one atom. They are free to flow throughout the metallic solid. So this gives it specific properties like going from soft to hard depending on the metal, low to high melting point, and making it a good conductor of heat and electricity. And notice that the other ones in their solid forms are not good conductors of electricity. So if you see that a crystal is a very good conductor of heat and electricity, you know we're talking about a metallic bond, a metallic crystal, because it has metallic bonds that allow the electrons to be delocalized and make it a good conductor of heat and electricity. So try to pick out the things that are very, very important and maybe some examples that can help you remember the properties and the tools to remember the forces that hold them together and why they have the properties that they do. So for example, molecular H2O, when it's an ice cube, is actually something that is a molecular crystal, and we know that it's soft, has a low melting point, and is a poor conductor of heat and electricity. But a metallic one can be any of the metals. So choose your examples carefully so that you remember the different properties so that it's easier to identify and then to compare the crystals.